So we started the idea of factorization, which was putting the brackets back. You'll notice that we're factorizing all of the expansion methods that we did before. So we went back and did common factors factorization. We did difference of two squares factorization today. Two types of factorization. The first is perfect squares factorization. These are the rules. If you've got a squared plus 2ab plus b squared, it factorizes back to a plus b all squared. Or if you've got a squared take 2ab plus b squared, you've got a take b all squared. Get the rules down, but then I'll take you through the steps. All right, what are the steps involved? All of these factorizations, they will always say, try common factors first across all the terms. How do I double check if it's perfect squares? Check that there are 3 terms. 2 of the terms have to be square numbers. These are a squared and b squared. If both of these things in step 2 are true, check if the third term is a result of 2ab. And if that is true, you can apply this rule above. So again, step 1, try common factors first. Check if there's 3 terms. See if 2 of them are square numbers. Can we try A together? A. Is A 3 terms? Yes. Yep. Is x squared a square number? Yes. Is 49 a squared number? Yes. Okay, so let's write that. X squared is x being squared. What do I square to get 49? 7 squared. So we have met 2 of the requirements. The last check. Is the third term, the one in the middle, is that the result of 2 times by a times by b? What is a? X. What is b? 7. What's 2 times by x? 2x. Times by 7? 14. Is that what we have here in the middle? So perfect squares will work here. So what is the rule? We're using this one because it's a subtraction. So that's going to go to x take 7 all squared. That is my A, that is my B, and this 14 is 2 times by x times by 7. A is what you'll mostly get, but because I write your tests, I'm always going to chuck in something like B. Try common factors across all terms first. You look at that and you want 8 to work. Is 8 going to work for 18? Then you go, 24 and 18. 6 goes into 24 and 18, but does 6 go into 8? So we need to think about all this. Think preempt, because you need square numbers. You need 2 terms that are square numbers. Okay? What square number can I get out of 8? What's the only square number I can multiply into 8? 4. How am I going to make that negative 8 into 4? What could I divide all of these by? Good. Remove negative 2 as a common factor. That's why step 1 is here. If I remove negative 2 as a common factor, what's going to be left over with negative 8? What would I have to times negative 2 by to make it good? 4x squared. If I've removed negative 2 from negative 24, what would be left over? What would I have to times negative 2 by to make it negative 24?
Plus 12.
Positive 12, well done. And what would I need to times negative 2 by to get negative 18? What kind of a 9?
Positive.
Okay. There's no arbitrary reason why I did negative 2. Because if I've removed negative 2, is 4x squared a square number? What do I times by itself to get 4x squared? 2x. What number do I times by itself to get 9? 3. That's my A and that's my B. So my A is 2x squared. That's my A. What's my B? 3 squared. And what's that little check? Check if the third term is a result of 2 times by A times by B. 2 times by A, which was 2x, times by B, which was 3. What's 2 times 2x? 4x. 4x times by 3, 12x. It all fits. So now I can use this shortcut. I believe we're using this one, the top one now. What is my A? My A is 2x plus B, which was 3, all squared. Am I forgetting something? I used the rule, but there's still a negative 2 out the front, yeah? Don't forget that. That's worth marks. That's perfect squares. Step one to I think that's an Ignite question. The other one is just assume knowledge. Okay? Can you get those 2 down, please? What I'll do is teach everything to start off with, and then I'll tell you the timeline practice to do. A couple of minutes to, and 35, I'll get back to you.